Hi everyone, this is just a short lecture on qualitative and quantitative data analysis. Um, the lecture itself probably won't be all that long, just about 12 minutes or so, and then at the end what I'll do is I've got some information about the in-class presentation, including the templates, and so I'll switch over to those slides at the end and just run through them real quick. So all in all, video should be about 15 minutes or so. So this is about qualitative and quantitative data analysis. And remember, there's a difference between qualitative and quantitative that's probably important to know. Qualitative research uses spoken or written words as its data source. It's interested in capturing emotional content, the sentiment, the process of things that are really, really hard to quantify, perhaps impossible to quantify. Qualitative research typically has smaller sample sizes, and researchers are not trying to generalize. They're not trying to sort of develop some lessons that can be applied to the population at large. They're only concerned about the people who actually participated in a qualitative study, which might only be 10 or 15 people. Quantitative research, on the other hand, uses numbers typically to specify a quantity or amount of some construct. Remember, we do quantitative research in an attempt to take lessons that we've learned from studying a sample of people and try to generalize them to a population of people. So we're trying to sort of improve life for a big group of people by studying a small group of people in quantitative work, and we do that really by giving people surveys and then analyzing the data in an attempt to generate some lessons that we can use to sort of make some application to that population of people. Most of what we've been talking about this semester has really been quantitative data, so sampling procedures, measurement, levels of measurement, research questions. Typically, that stuff applies to quantitative work. So, a couple of steps in the qualitative data process. First thing you have to do is transcribe the data. The interviews or focus groups, like we talked about last week, are often recorded, and those recordings you sort of have to go through them line by line and transcribe the data. It takes a very long time to do, and it's incredibly tedious work. Second thing you have to do is establish some rules for the analysis. Who's going to analyze the data? How are they going to do it? Where are they going to do it? What kinds of things are they going to be looking for? And the point of this is that this is what makes the analysis sort of systematic and rigorous. This is what gives the analysis sort of some credibility. Third step then is to do this thing called first level coding. And that's literally where people go line by line through the transcript that you created in the first step and look for meaningful units. Could be a group of words, could be key phrases, could be key sentences, right, or even key paragraphs. Often it's just key phrases. But then you're sort of creating categories to which these meaning units can be assigned. And then you have to go through and assign all of those different meaning units or those key phrases and key ideas. You have to go through and assign them to the different categories. The thing to do after that is then to sort of define and reorganize categories. After your categories are fairly well cemented, the next thing to do is to start combining those categories, comparing them, and building categories at sort of higher and higher levels of abstraction. And what that sets you up to do is start to look for meaning, which is just about the second to last step in qualitative data analysis. And what you're really doing when you're looking for meaning is coming up with an explanation for why the diversity of categories exists in the data. What's sort of the story that sort of ties everything together? The last step in qualitative data analysis is really assessing the trustworthiness of the results. It could be member checking, which is where you go back and present sort of findings and categories and things like that to people who were part of the focus groups or the interviews. You could compare across researchers, which is where researchers compare the categories that they've come up with to see if they've come up with similar kinds of results. Or you can test results with more data. So that might be data that you reserved specifically for this, or data from another focus group or interview that you didn't include in the analysis. For as much as these steps are sort of presented in kind of an order, this is often pretty done sort of as a pretty iterative process. So people do sort of first and second level coding, looking for meaning and assessing trustworthiness. They sort of do that over and over and over and over again. There are a few formal qualitative data procedures. I've just listed a couple of them here. Things like narrative analysis, thematic analysis, discourse analysis. They all sort of follow the steps that I laid out on the previous two slides. Arguably the most sort of arduous and rigorous and sort of gold standard of qualitative analysis is probably grounded theory. And that's actually done when people have very little prior knowledge of a given subject, and they're actually trying to create an entirely new theory. So the sort of process of coming up with an entirely new theory is actually done here. It's that theory that sort of ties together all of that sort of diversity of categories. It's very difficult to do grounded theory, primarily because people almost always have some prior connection to the topic, but there are some sort of offshoots of grounded theory that people use when they have prior knowledge. But again, the grounded theory is probably sort of the gold standard of qualitative analysis. A few things to remember. Qualitative research is really best for areas where it's hard to study them quantitatively. Either the quantitative methods don't exist, or they just sort of don't lend themselves to it. But qualitative work is really about capturing depth and meaning and process. It's not, and nor does it claim to be, for creating big generalizable lessons that can be applied to populations of people. What it's about is capturing the experiences of people with similar experiences. And good qualitative analysis takes a long time, like months and months and months. Only a handful of my papers are qualitative, but I mean, we worked on some of the analyses for these. There were two of us that did it, and we worked on the analyses for 5 months. We then checked with experts, other people who had been part of the focus groups and the interviews, and then went back and spent another month refining our categories and things like that. One of the other papers that I did, it took us 3 months to analyze the data. So it takes an exceedingly long time to do really good qualitative work. Okay, quantitative analysis. Let's shift gears here a little bit. People often associate quantitative analysis with statistics, and that's true, but there are often quite a few preparatory steps, including scoring measures, entering data, examining missing data, looking at dropout, attrition, things like that. There are lots of specialized packages, computer packages that people use for quantitative analysis. Some of you may have heard of before. It's okay if you haven't, but SPSS, which is a statistical package for the social sciences, is a commonly used one. So are SAS and R, M+, and there's others out there too. Most of the stuff we're going to talk about today can be done in Excel, and I'm not going to ask you to do any of these things in Excel, but you should know that you can do these things in Excel. And the reason for that is that sometimes clinicians are asked to do some of these things, and Excel is pretty much ubiquitous. So you would simply have to consult with me if you were asked to do some of these things. So quick reminder real quick of quick reminder of the different levels of measurement. We're generally concerned with 4 levels of measurement, although sometimes the last 2 are sort of condensed into a single category. So there's nominal measures. Nominal simply means name or category. Nominal variables cannot be ordered in any way. Gender, race, religion, whether or not someone likes cheese, favorite pizza topping, these are all sort of nominal categories of things, typically very descriptive in nature. Ordinal variables are nothing more than ordered categories. Think income, think level of education, that kind of thing. Interval variables are equally spaced on a continuum. They don't have a meaningful zero. The best example I can think of for that is some measure of psychopathology, symptomatology, severity, something like that. And then a ratio measure is, again, equally spaced, a continuum, but there is a meaningful zero. So it could be the grade level that one is achieved, could be a person's age, could be the number of children one has, that kind of thing. Let me just move myself real quick. Two things to remember. Like I said before, interval and ratio are sometimes combined into a single category called a continuous variable. And the level of measurement, this is the second thing to remember, the level of measurement determines how the data can be analyzed. It determines exactly what you can do with it. So a couple of things to know. Descriptive statistics, mean, median, and mode. You may have heard about these before. They're called measures of central tendency. Mean is simply the average. Median is simply the number that occurs in the middle. So you line up all the scores from highest to lowest, and you take the one that's in the middle. That's the median. And then the mode is simply the number that occurs most often. Like I said, these are called measures of central tendency. There are a couple of different measures of variability. Range is simply the difference between the highest score and the lowest score. Standard deviation, this is a measure of dispersion, and this simply tells us how far away from the mean scores are. So when we start to think about standard deviations, this is where we get into studies of the normal curve, or the bell curve. It's also sometimes called student's curve, or the T-shaped curve. Any of those names would be the same thing. But this simply is a measure of sort of a normal distribution of scores. And so the mean, let me find my cursor, the mean is right here in the center. And most scores on a given measure of something cluster right around the mean. So they're either a little, they're right at the mean, they're a little bit ahead of it, or they're a little bit behind the mean. In fact, in a normal, like a normally shaped normal curve, a standard shaped normal curve, 68% of the scores fall between one standard deviation below the mean and one standard deviation above the mean. And 95% of the scores fall between two standard deviations below the mean and two standard deviations above the mean. And then just about 100% of the scores fall within three standard deviations, either above or below the mean. So if something's ever called an outlier, that simply means that it lies really far away from the mean on a normal curve. It's way out here in the tail, in either one of the tails, either the small tail, the little tail, or the big tail, which simply means the score is high. And sort of statistically speaking, an outlier score has a less than 1% chance of occurring. So 0.3% of scores, I'm sorry, 0.3, I was right. 0.3% of scores occur outside of three standard deviations, and we have to divide that in half because those scores could be high scores, or they could be low scores. So 0.15% of the scores are three standard deviations above the mean, and 0.15% of scores are three standard deviations below the mean. So it's outliers, sort of by definition, are exceedingly, exceedingly rare. Measures of variability, like standard deviation, are typically used when you have continuous variables. You can't do a standard deviation on an ordinal variable or a nominal variable. You need a continuous variable. You need a ratio or an interval level variable. And the reason for that is that people basically need to be able to cluster around some kind of mean. And given sort of most measures of continuous variables, most scores will distribute themselves in this sort of normal distribution. So you'll have most people, falling right at the mean of some continuous measure. So other terms to know: inferential statistics. That's a group of statistics that are used when we want to make some generalizations to a population, but we only have a sample of people. Inferential statistics adjust for error that might be present in the sample. More on that in a second. And these include things like a chi-square, a correlation, a regression, an ANOVA, a t-test, and lots and lots and lots and lots of others. But these are the ones whose names you should have at least heard. I probably wouldn't ask about these on a final exam, but like I said, I just think it's important that you've heard about them, or at least heard the name of these things. One thing I might ask on a final is about this idea of statistical significance and the term that we're going to talk about on the next slide, which is clinical significance. So statistical significance is simply when the p-value on some inferential statistic is less than 0.05. It's sometimes written as p less than 0.05 or p equals 0.00 something, something similar like that. The thing to be aware of, though, is that statistical significance is not the same thing as meaningful. These are not the same things, although in common discourse, they are often presented as the same thing. This idea that statistical significance is cut off at 0.05 is actually completely arbitrary. It was set up by a statistician about 100 years ago, simply because he thought it was a good idea. He actually thought that the 0.05 cutoff would be replaced with something more meaningful, but unfortunately it hasn't. What the 0.05 actually means, if the inferential statistic returns a p-value of less than 0.05, it simply means that there's a low probability that the error occurred by chance. And this is actually a callback to the comment I made here on this slide, which is right here, in that inferential statistics adjust for error that might be present in the sample. The p-value is simply an indication that it's very unlikely that there's an error in the calculation based on information we have about the sample. So like I said, it really is an indication of the quality of the statistical test. It has absolutely nothing to do with how meaningful or how useful a given result is. A better term is probably clinical significance. And what that really means is does the client feel better? Is their life improved? Did their symptoms decrease in such a way that they no longer need services, or they can reduce the amount of services they're consuming? There is no test for clinical significance. It's up to the clinician to use their judgment. But clinical significance, like I said, a much better term than statistical significance. Okay, we've reached the end of this lecture. What I'm going to do real quick is just pause the video and switch over to the other presentation and just give you a few words about the presentation for the December for our last class. So what I've done is I've actually created two templates that you could use for the presentation in our last class meeting. Presentation itself should probably be 10 to 12 minutes. If you go to 15 minutes, that's fine. I don't think you need to go much longer than 12, though. And then that gives us a couple of minutes for questions. So this is the first template I developed, and this is on Moodle. I'll show you the second template here in a second. You're welcome to use these if you like. You don't have to. You're more than welcome to create your own. If you do use these, you're more than welcome to adjust them however you like. They're both pretty basic, so you should feel free to adjust them however it is you need to. What you should do is come up with a title, obviously, for your talk and put your name on it, but then just give us a brief introduction or an overview. You should discuss the theoretical framework that you use to understand the problem, if you do in fact use a a theory to sort of understand the problem. And then you should give us a couple of slides on some of the key lit review findings. And this is information that's taken right from the paper that you're going to submit later on towards the end of the semester. Where the presentation diverges from the presentation is in this research proposal part. So you're going to come up with a proposal. You're not actually going to do this scholarship. This is simply a chance for you to apply some of the concepts that we discussed in class here. And what I've done here on these sort of, what is that, 5 or so slides, I've touched on the things that I think you should focus on. So based on the information in your lit review, up here, what you should come up with is a research question and a hypothesis, and you can use one of the research question forms that we spoke about in class. You should tell me what your independent variable are and what your dependent variable are. You should mention a research design, whether or not it's going to be cross-sectional or longitudinal. And if it's going to be longitudinal, what kind of design you're using. You should tell us how you're going to select your sample, whether or not you're going to use a probability sampling method or a non-probability sampling method. You should tell me how you're going to measure the variables in your study. At the very least, you're going to need measures for your dependent variable, and depending on what your independent variable is, you might need measures for that as well. If you can find the measures, that's great. I can help you find measures typically. I have a number of them that I'm happy to share with you. If you can't find them, or you find that you have to pay for it, you can simply give me the name of the measure. That would be fine as well. And then what you want to talk about are in this last slide, that's not letting me, there we go. Nope. Just adjust this real quick. In this last slide, you want to talk about limitations. And so these are threats to internal validity that we also discussed in class. Any threats to internal validity that you think might be present. So real quick, let me just show you the other the other presentation template that I developed, and then we'll end this presentation or end this. So this is the other template that you're welcome to use. This one is just one slide as opposed to the other one, which was sort of a series of 8 or 10 slides, whatever it was. You're welcome to use this if that's easier, or if it sort of fits your presentation style. With this, you should very much feel free to sort of reorganize these and stretch them out and adjust them however you need to. But like I said, if you'd prefer to, you're also welcome to sort of create your own presentation slides. Either is fine with me. So last thing I will say is, as you're working on this, if you get stuck or if you get sort of jammed up, don't hesitate to get in touch with me. This is sort of practice for the capstone that you'll put together in a couple of semesters. This is, like I said, a chance for you to apply some of the research concepts that we learned about this semester. So if you run into a wall, that's a good time to consult with me. All right, thanks for watching. Bye-bye.